We're going to be working on evaluating powers today, so go ahead and copy on your target. It's pretty nice and short, which is great. And I want to make sure you guys understand what I mean when I say powers. So within this 2 to the 7th, we have a base, we have a power, and we have an exponent. What is each one? Label the 2 to the 7th. Well, the 2 is the base. The 7 is the exponent. So what is a power then? Is the 7 also a power? Well, we read this, we say 2 to the 7th power. Actually, the whole thing makes a power. Okay, so base is the number that we're talking about. The little number that we raise it to is the exponent. That's going to tell us how many times we have that base being multiplied, and the whole thing is a power. So 2 to the 7th is called a power. If a number is in exponential form, the exponent represents how many times the base is to be used as a factor. The exponent represents how many times the base is to be used as a factor. So for example 1 here, I have 3 examples. I want you to write all 3 of them in exponential form. Meaning instead of having 4 times 4 times 4 times 4, how can I write that using a base and an exponent? Well, I have the number 4, that's my base, and how many times do I have it? 1, 2, 3, 4, so it's 4 to the 4th power. You can do it with variables too. Look at B. Write d times d times d times d times d in exponential form. You write your base and you write your exponent, which is how many times you have that d, so d to the 5th. What about the third one, C? -6 times -6 times -6. You're going to want to keep those parentheses. That means -6 is my base, and how many times do I have that -6? 3 times. Okay, so that's exponential form. No big deal. I want to make sure you're comfortable evaluating exponents. Remember, when you evaluate, it might help you to write it out, and this is your only work that you can show. So it's a good idea to write out what you're multiplying. Also, it's very important that anytime you have a negative number, you always use parentheses, okay? I just always use parentheses no matter what, anytime I substitute. But always use parentheses to raise a negative number to an exponent. So for this first one, for A, I want you to evaluate it. I want you to first think about expanding it out. What does 3 to the 5th power really mean? Well, it means you have a base of 3 and it's being multiplied by itself 5 times. Okay? Order of operations then would tell you to do these 2 and get 9. But you could do another 2 if you want. So this is another 9, and then times 3. 9 times 9 is 81. And what's 81 times 3? 3 times 1 is 3. 3 times 8 is 24. What about B? Expand B out. Since the -3 is the base, and that's what's in parentheses, you actually have to write out -3 times itself. Don't forget that negative with it. You can use parentheses on this part here, or you don't have to. Okay? Now remember, what's -3 times -3? Well, that's going to be a positive 9. Negative times a negative makes it positive, so negative and negative makes a positive 9 again. Then times that -3. So we're going to have a positive 81 times a -3. Same answer, different sign. So that sign does matter. Okay, what about -4 to the 4th power and 2 to the 8th power? Pause the video, expand those out real quick, and then press play. So on these two, you should see -4 times -4 times -4 times -4. It's going to be 16 times 16, which is going to come out to 256. On the bottom one, lots of 8s. I'm sorry, lots of 2's. And I might even do some of these together. 2 times 2 times 2, well, 2 times 2 is 4, times 2 is 8, times another 8, times a 4. What do you get here? 8 times 8 is 64. What's 64 times 4? 256 again. Okay, so hopefully you checked those out. You got them all right. I do want you to look at the bottom here. We have 4 problems. They all look very similar. They all have 5's and 2's. Take a second and write what you think each one of these comes out as. Okay, so go ahead and write it right now while I'm talking to you. It's very important that you understand that the placement of the negative makes a difference on what your base is, and it also makes a difference on what your answer is. Okay, it doesn't always give you a different answer, but it does affect what the base is. Okay, 5 squared is just 25. On this one, we have negative 5 times negative 5, so we get a positive 25 again. Notice, same answer, different bases. Now on this one, what's your base? Well, the base is only what is directly in front of the exponent. So the base here is 5. This negative's just hanging out front. Or think about it, guys, when you have a number outside of parentheses, maybe you have something like this, what operation's happening right in there? Multiplication. Well, that's actually here too, but if we just have a negative out front, it's actually a negative 1, okay? So this is really negative 1 times, and then 5 squared. What's 5 squared? It's 5 times 5. So negative 5 squared is going to give you a negative 25. Look at this last one here. This is always the one in question. Okay, what's the base? Remember that the base is only what is directly in front of the exponent, unless there's parentheses. So here, what is directly in front of this exponent? 5 or negative 5? Just 5, guys. 5 is the base. This negative is out front. If I wanted negative 5 to be the whole base, I would have to write it like this. So here, this is the same as negative 1 times 5 squared, or negative 1 times 5 times 5. So this is negative 25 as well. Here's the big difference. Look at these 3. Okay? If the negative is not in parentheses, your answer is negative. If it is inside the parentheses, now it's getting squared. In this case, your answer is positive, okay? We're gonna extend what we know about these positive and negative bases with even and odd exponents on the back, okay? But make sure you have the star reminder written down. Make sure you have these examples written down, and then go ahead and turn over to the next example. Now that we can feel comfortable with exponents, I just want you to practice simplifying with exponents. So remember, anytime you simplify, that's please excuse my dear and Sally. So you always want to start with parentheses. Inside these parentheses, I have exponents and I have subtraction. So let's start with the exponents. What is 2 to the 5th power? What is 3 squared? You don't have to expand those out here. If you need to, you can always do it on the side. So maybe you don't know 2 to the 5th quite yet by memory. You will get to there. 2 to the 5th is going to be 4 times 4 times 2. So that is 16 times 2. So that's 32. Minus 3 squared, again I'm just squaring the 3 and pulling the minus sign down, is 9. Order of operations still inside the parentheses, I have negative 2. 32 minus 9 is 23. And then plus 6 times 4. Order of operations, now I'm ready to do the multiplication. Negative 2 times 23. Negative times a positive. Negative 46. And 6 times 4, 24. Last step then, adding same signs or different signs here. Different signs, so you subtract. 46 minus 24 is going to give me 22. But the larger digit is negative, so my answer is negative. Go ahead and try B. If you want to try it without me, go ahead and pause the video. If you want to do it with me, here we go. Again, on B, we're starting inside the parentheses. What is 5 cubed? 5 times 5 times 5. 5 times 5 is 25. 25 times 5 is 125. Think about it if you have 5 quarters. You have $1.25. 4 times 4 times 4 times 4. 4 times 4 is 16. We already had this one. What's 16 times 16? Do you remember it? 256. So we have 125 plus 256 being divided by, let's do this exponent too. Careful with this one. You have a negative 3 squared. Is that negative being squared or just the 3? Hopefully you're saying just the 3. So we would have, this is really a negative 1 times 3 times 3. Are you dividing by 9 or negative 9? Negative 9. Okay, let's finish adding up what we have in the parentheses. We have 381 from adding these two numbers. 381 divided by negative 9. Take a second to do that. Try not to use your calculator here. Just think about long division. You don't even have to set up the long division. Maybe you're setting it up in your head. You're looking at how many times does 9 go into 38? What's your remainder? And then how many times does 9 go into that remainder with a 1 behind it? So 9 into 38. 9 times 4 is 36. We get 21. 9 into 21, 2 times will give me 18. And we have a remainder of 3. So you could say this is negative 42 and 3. What denominator do I have? Well, I divided by the 9, so 3/9. I can reduce that though, so it's negative 42 and 1/3. You could also set it up as a fraction and just reduce it. 381 over negative 9. What are they both divisible by? Since it's not going to come out as a whole number, just reduce it down by 3. And you would have a negative 127 over 3. All of these would be good answers. All right. Fourth example here, so let's put in a word problem. You actually will use this formula later on. The number of diagonals of an n-sided figure is given below. Use the formula 1/2 times n squared minus 3n to find the number of diagonals in a 7-sided figure. What I mean by a diagonal, if I have a 4-sided figure, how many diagonals can you draw? I can draw 1, 2. If I have a 5-sided figure, how many diagonals can I draw? Well, I have a diagonal here, and I have a diagonal here, and I have a diagonal here. Oh, I also have one here, and I also have one here. So instead of having to draw all of these, we want to just use this formula. Figure out how many diagonals a 7-sided figure would have. Well, n is the number of sides, and we know what n is, guys. What is n? 7. So you're plugging it in. You're substituting the value of 7 in. Anytime you substitute, I like to use parentheses. I just like to be in that habit now. Go ahead and simplify then. Where would you start? Hopefully you're telling me you got 7 squared, which is 49. And then minus 3 times 7, which is 21. 49 minus 21 is 28. And 1/2 of 28 is 14. So you would have 14 diagonals. All right, take a look at the last thing on the notes sheet here. It says, let's take it a little bit farther. Complete the following charts with your own examples. There are 2 examples in each one to get you started. So every problem, I want you to add some more, all these tables, following the titles that they have. Once you've done with that, I gave you 2 examples on each one, okay? So just make sure every value in this first table is a positive base and an even exponent. Any one you want to do. I would do numbers that are small, like 1, 2, 3, and then this one's going to be a positive base and an odd exponent. Once you finish all 4 tables, see if you notice a pattern. Does it matter if your exponent is positive or negative? Does the sign of the base change your answers? Maybe it does only for certain cases, okay? So write a little written response there to let me know what you think.